Hello, good morning. This is Solomon Igari from Eloquent Data, and today we're going to be going through steps it takes to perform a data analysis. It's going to help you for your capstone project where you're supposed to answer some questions around malaria in Africa. So this is the task you're given. Can improve drinking water and sanitation facility and preventive measure decrease the risk of malaria infections. So you'll be asked several questions like this, like up to four questions, and then you will use this data set over here to answer those questions. So how will you approach such challenge? I know we're giving you different skills to solve the problem, but there's a framework. There's actually a framework that will make your work easy when you face with any data challenge, any data analytics challenge. Just follow the framework, and then you come up with your the right answers. So that's what we'll be treating today. Um, the steps to take while performing data analysis. So there are five. So these are the five different steps. You have to process and clean your data. You have to get to know your data. Very, very important. You have to get to know your data. You have to test the hypothesis. That's like answering those questions. See if you can if from the data if you can get answers to those questions. And then you need to check for robustness. And then you finally prepare your documentation. So I'll take you through the steps one by one. So process and clean your data. This activity also has a lot of steps underneath it. So while you're processing and cleaning your data, you need to load the data into a statistic analysis program. So either Arrow, you can do this with Python. You can use your Jupyter Notebook for that. Some people use SAS, some use MATLAB. So depending on the environment you're comfortable with, you have to import this data. So usually these data are of there are different data sets, but luckily for us we have a single data set. But if you're faced with a challenge outside the academic cycle, usually you have data from different tables, different data sources, different channels. So you have to merge these data sets as needed, rename the variable name. Like I think this our data is fairly clean, so you don't really need to do much about renaming it. Yeah, it's clear. Country name, yeah, country code, yeah, it's something you can identify. Let's take for example, you have something like column 1, column 2, maybe a different name, a generic name that was given to it from the database. So with that, you have to rename your column so that it will be easy for you to work with when you're performing your analysis. Then you can recode variables, so you have to handle a lot of it's more of you, let's say, calculating or measuring your variable. So let's take for example, maybe we can get a good example from here. But if you're in the health sector, to calculate your BMI, you divide the weight by the height or something like that, or height by weight. I don't know. But you have to create a new column. This during the cleaning process. During cleaning and processing, that's when you have to create new columns that will help you your analysis. So you also need to check for errors and consistency. So you look for inconsistency, look for impossible value. So if you're dealing with age for human, you see something like 100,000, then there's an error somewhere. So look for those outliers that doesn't make sense. Not all outliers you would delete. Definitely, if you're solving a problem around fraud detection, but outliers are very important. But in the case that it's obvious that outlier doesn't just make sense, you take it off. and you have to fix errors. So errors like missing values, duplicate values, and stuff like that. Just you just know how this is the stage, the processing and cleaning phase. That's where you handle this, and that's what takes chunk of your time. Like most of your time in data analysis, it's you cleaning, processing, and understanding the data. So I'll talk about on getting to know your data next, but the cleaning takes a lot of time. Some people just jump straight to the analysis. I wouldn't advise you to do so. Don't just jump straight to your analysis, because you will not fully understand the problem. You will not fully understand your data. And if you don't understand your data, you don't understand the problem, you can dig deep. You can just do a normal general overview or normal general analysis, but you have to understand what you are solving. So back to this. The next step is getting to know your data. Very, very, very important. So you're done with cleaning, you've meshed your tables together, you've removed duplicates, you're filling your missing value with whatever statistical algorithm or arithmetic operations you want to fill it with. We'll talk about filling missing data later. So let me say you're done filling your missing value, and then next you want to know you need to know your data. So how do you do that? You need to calculate the distribution. First and foremost, it's easy to just, the first step is just to visualize. Just visualize your data. If it's a category variable, do a bar chart. If it's numerical, and you can do histogram to see the distribution. Just visualize your data any format you feel like. You can do pie charts if it's a category with few samples. You can do a pie chart and see the chunk, but just try to visualize data to understand, or to get a few understanding of the data. Then you can test for distributional assumption. So you can start comparing columns. Start comparing columns, and this will make sense. This is where you start. This way you will start testing some of your assumptions here under the tags. This way you start testing some of your assumptions. Oh wow, does if countries that have improved drinking water and sanitary facility, do they have high malaria cases? This way you start testing those assumptions. Then you also need to understand each variable. Yeah, before you even start all these things, you need to understand each variable. So this boils down to um, domain knowledge. So this malaria in Africa is more of environmental issue. So at least most of us know about malaria. So it's quite general. But if you're dealing with something in the health sector, it's okay to go make some research around that topic in the health sector. You need to know what you're tackling. You need to know what you're handling. If it's in agricultural sector, you need to know that. So you need to understand each variable and what this variable does, what it entails. Sorry. So afterwards, after you've studied and understanding the variable, I've said it before. Then you start exploring relationships. Like how does this correlate to this? Do they match? Do they how do they make sense? Will if you countries with high drinking water standard, do they have low malaria cases? Test these different assumptions. Once you start checking the check for correlations between variables. There there are different um, statistical formulas you can run with Python that will make your work easy, or with Arrow. Sure, Arrow is a statistical language. So there are functions you can just run on your table, and it will not just give you the value, it can even give you some kind of visualization that can fairly go through. You can go through it and then easily pick out areas that have high correlation and low correlation. So histogram correlation tables will be very, very important in visualizing your data with the steps. So after you've bought, let me say, 80% of your time, um, what trying to know your data and process and clean your data, then you have to test the main hypothesis. Now you've seen this correlation, you've seen the correlation here, it correlates. Now you want to test it. This is where you start creating some visualization relationships. Yeah, we've seen that they correlate. Let's plot the graph. Let's see how the areas with clean water sanitation, how it correlates with areas with low malaria cases. Plot your graph. This is where you this the testing of my hypothesis. This is where you answer those questions based on the knowledge you have from your data. So you've known your data, now you start answering all those questions under here. Create visualization. Don't worry about making the visualization code right now, because you're going to work on that in your final documentation. But this is you need to know the right charts to use for the right analysis. If you're running a machine learning model, this is where you run your model. You compare observation, you interpret results, you follow your analytic plan. um, yeah, you run your model, test your model, improve the model, do your feature engineering. This is where you do everything. So afterwards, you after you've tested your model, the issue with most data scientists, they just want to jump straight to this point without understanding or cleaning your data. Oh, you can't do that without cleaning data. But sometimes, depending, if data is fairly clean, like the Maria case, you can skip the cleaning, but you have to understand. But we just jump straight to start testing assumption without trying to understand the data. It doesn't work like that. You may create something, but it won't be that in depth. So afterwards, you have to check for robustness. So this checking for robustness is you trying to break your system. So you've checked. You need to make sure that um, when a new variable is being introduced to your model or to your assumption, it doesn't break the whole process. So you try to break the process yourself. You conduct various analysis. So you will also need to consider the totality of your evidence. This way you also need to state any assumption you took. It could be easily replicated somewhere else, because you're writing. Oh, if it's a research, okay, even if it's not a research, that it could, yeah, you can easily duplicate it. People can replicate your model, and it will work the same way you said it's going to work. So this way you have to break your model. If there's any assumption you took, this way you have to state it down. And then you also need to watch for biases over here. It's very, very, very important. So you need to check for solution bias. People having to issue. Okay, so solution bias. Example, I have this survey. Let me see. You send the survey for to check, let's say, malaria example. So most likely people that have suffered or experienced this malaria issue, those are the people that will fill the survey. So it's going to tint your survey towards those that it affected, but you need to get a general survey from people, both those that it's affected and those that um, it has not affected. Okay, that won't be a clear example. A very clear example is maybe eating habits. So if you're trying to conduct a survey of people's eating habits, most likely people that have bad eating habits are those that will want to fill the survey, because maybe they feel that their eating habits is causing them some health issues or making them go fat. They'll want to fill that survey more than the healthy ones with a good eating habit. So you need to make sure your solution is not doesn't contain biases. So you look for solution bias, then you also look for self-reporting. So self-reporting, let me give an example. A solution that is not reported by a professional. So let's take an example, a very sensitive issue like gender-based violence. Let's say the rape issue. So some people come up to social media to say that they are victims. Um, this then you also have another set of data, let me say from the hospital. So those are two separate data, self-reporting hospital. So the self-reporting, there's no much evidence to back that up. You could also take it, you could classify it as self-reporting in your analysis to let people know it's self-reported. Another example is maybe this COVID-19. Those that have symptoms of COVID-19 but did not go to the hospital to verify. Or maybe after a while, the symptoms cleared off. Are you going to classify those people as those that have COVID-19 because you've not verified it? Those are self-reported versus those that went to the hospital and reported themselves for COVID-19. So you need to check all this bias, check your limitations, and try to and your assumption, bias, limitation, assumption, and try to break your process. So finally, once you're done with these four steps, that's when you start preparing your documentations. So you need to make it well readable. Your code should be properly documented. Yeah, commented. Sorry, properly commented codes. So you need to settle with from all the visualization you created during your testing of hypothesis and get to know your data. You need to select the ones you use for your final results. You need to select the table. You need to select the figures. Um, you need to follow guidelines in formatting. So in case you're writing a journal to any publishing firm, you need to follow their guidelines for tables and figures, and then you need to make them publication ready. So you give out sufficient code that can be reproduced. So you don't just give chunk of your code. You have to put sufficient code that people can from that code reproduce your solution. Um, then okay, yeah, improve graphs and improve your graph, improve your tables. You follow standards. You can use very good improve them color scheme for your graphs and table. Increase the resolution and also the font size. So that will help. So every step every step we took here was from a lecture, a Stanford lecture by trying to get her name. Yeah, Kirsten Cianani. Yeah, it's how to analyze research data. You could check it out to get more insight. She did a very wonderful work on the data analysis steps. And you won't find it difficult to come up with answers for every question that was given in this task. Okay, thank you very much for that. We'll clear off the analysis part. So for the Python tags, I think the Python is straightforward. So you have to go to your not code. You have to go to your learning. Under course, then go to Python and try to clear off the exercises here. It's straightforward. Make sure you take the tutorial for clarity. Then let's open that and also open this. So this is the tutorial. Simple. This is hello Python, and they are printing the statement. This is a print statement. Alright, cool. So this is the print statement. This is a variable declaration. You're printing out that variable. It's going to give you 0, and you're adding for the variable. So this is how you add for and then reassign. I know this will make a lot of mathematicians run mad, because like x is equal to x plus 4. If you take x over here, to be x minus x, which is 0, which doesn't make sense. Yeah, but this is programming. This is not mathematics. So this is what you do. You add 0 to 4 and then reassign it to your spam account variable. So spam account is 0 plus 4, making it 4. Now spam account is equals to 4. So that's how it works. So if spam amount is greater than 0, then print this statement. Then your Viking song is equals to spam times amount. So you have 4. So Vikings song is gonna be spam, 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 spam. Yeah, 4 times. So cool. So this is the learning here is quite fun. Go through it. Once you're done with that, then it'll be easy for you to face the exercise. So it's just straightforward. You're printing out this to successfully run your code. Once this code runs successfully, then you can start to work. So I'm starting up the session. It takes time to spin. Yeah, cool. I think that's engaged the they started the CPU. How come my CPU is red? Just late stuff. Oh, cool. So it's ran successfully. So afterwards, try to get the question what they want you to do and solve the answer. So you have your question 0. So this is to set up your environment with a binder, and then you start answering every question downwards. Cool. Read the comment for the question, read it for the question, answer. Once you answer, there's a check here to check your answer. So it's going to tell you if it's right or wrong. Alright, so I'll be ending the section now. So we'll share the video afterwards. Thank you everyone.